Okay, so welcome to all the students and very warm good afternoon to all. So we already started the new topic of vacuum technology. Okay, so vacuum technology is very important technique in the subject of thin film, and that fundamental concept which we already discussed in our previous lectures. So my first question is that what is mean by vacuum? What is mean by vacuum? And what is the definition of vacuum? So the vacuum is defined as a vacuum is a space. Vacuum is a space entirely divided, or we can say vacuum is a space entirely devoid of matter, or we can say that absolute vacuum. Okay, so that is the definition of vacuum. It means inside that vacuum there is no alternate air was present. Okay, so that's why the inside the bracket one word is there. Absolute vacuum means absolute only vacuum is available there. Okay, it means apart from vacuum there is no other elements are present. Okay, so that is nothing but a vacuum. A vacuum is a space entirely devoid of matter. Okay, or we can say in practice we talk about a vacuum when the air pressure in a space lies below atmospheric pressure. Okay, means air pressure is lie below atmospheric pressure, means below the atmospheric pressure there is air is present. Okay, so it means that we can say that in practice whenever we are talking about the vacuum, so you just remember in your mind, that there is high amount of pressure was present when the air pressure in a space lies below atmospheric pressure. It means inside the atmosphere there are maximum amount of pressure was present. It means the vacuum was present. Okay, so we know that what is the ranges and what is the unit of pressure or what is the unit of vacuum. Okay, vacuum is nothing but a or near about a pressure. Okay, so there are different kind of units are present to determine the vacuum. Okay, so generally one of the famous unit, that is the Pascal. Pascal is the unit to measure a vacuum, or we can say that Pascal is the unit to measure a pressure. Okay, and if we talk about the nanoscience and nanotechnology way, so whenever we need to measure a vacuum, that time we are use a bar unit. Okay, we are using millibar unit. So look at inside the picture, there is two figure. Number one, which is denoted in the unit of Pascal, and second figure indicates a millibar. Okay, and we can say that, or we can observe that GV is nothing but a rough vacuum. Okay, whenever we start the machine, oh, that is vacuum machine, so there is some rough vacuum is are there, that is 10 raised to 5 is the rough vacuum. Okay, rough vacuum means that much amount of vacuum is available inside the atmosphere, that is, or we can say in terms of 10 raised to 3 millibar. Okay, so that below rough vacuum, below the unit of, or below the range of a rough vacuum, there are some number, there are some types, that is medium vacuum, which is represented by capital FV. HV means high vacuum, and if there is very high number of vacuums are present inside the chamber, or we can say that inside the machine, so that is nothing but a UHV, that is nothing but a ultra high vacuum. If inside the technology or inside the system there are HV or UHV are present, it means high vacuum or ultra high vacuums are present, so that inside that system there is no other elements are present. There is no other materials are present except vacuum. Okay, and this kind of vacuum range are useful. Okay, HPU or ultra high vacuum, that kind of ranges. Okay, we can say that 10 raised to below less than 10 raised to minus 5 vacuum, or we can say Pascal. Okay, and if we're talking about the millibar, so less than 10 raised to minus 3 millibar to less than that. Okay, so that this kind of vacuum is required to accelerate the electron. Okay, this kind of vacuum technology is important to accelerate a electron. You already know the technology of electron accelerator, linear accelerator. Okay, or we can say that pelletron. Okay, so if whenever electron rotated in a cyclic orbit, or whenever electron knock out from that particular chamber, so inside that chamber there is required a very high vacuum. Okay, or we can say there is required ultra high vacuum, because inside that chamber, if there is some molecules are present, or we can say that there is some air molecules are present, so that air molecules is the main role to resist the electron, to struck the electron, to stop the electron's motion. Okay, so or we can say that to moisturize the inside the chamber, if there is some gaseous molecules or there is some air was present, so that the filament, whenever the electron was emitted out from that filament, so that filament may be moisturized, and due to that concept, vacuum technology is very important key point, and vacuum technology are used. Okay, and by using the high vacuum or ultra high vacuum technology to remove the unwanted air, to suck out all the elements which is available inside that chamber. Okay, so whenever that technique was started, so that much amount of millibar pressure was required, or that much vacuum is required. Okay, so now my point is that how we can measure the 10 raised to minus 3 millibar vacuum. Okay, or how we can generate, or how we can create 10 raised to minus 3 millibar vacuum. Okay, so by using the rotary pump is one of the technique to create a vacuum inside that chamber, inside that chemical vapor deposition technique, or we can say that physical vapor deposition technique. If we need to create a 10 raised to minus 3 millibar, so that cases rotary pumps are used. Rotary pump. Okay, rotary pump are used. Rotary pump. Okay, and if we need to create a 10 raised to minus 7 millibar vacuum, so in that case there is required a diffusion pump. Diffusion pump. Okay, so this technique is required to create a 10 raised to minus 7, or we can say 10 raised to minus 6 millibar or less than that. Okay, or if we need to create a less than 10 raised to minus 10 millibar vacuum, if we need to create a 10 raised to minus 10 millibar vacuum or pressure inside that chamber, so in that case there is required a a turbo pump. Turbo pump. Okay, so I hope that की तुम्हाला समजलं असेल टर्बो पंप कधी वापरतात आणि रोटरी पंप कधी वापरतात आणि डिफ्युजन पंप कधी वापरतात. ओके, गेटिंग माय पॉइंट. So that this kind of vacuum or this kind of pressure was required to create inside that chamber. Okay, and if that amount of vacuum is available inside that chamber, and if we start the chemical vapor deposition technique, or if we start the physical vapor deposition technique, and after that if we melt that particular element, whatever we want to deposit on that particular substrate, okay, so we will discuss in our next lecture, but we only focus on vacuum here. Okay, there are large number of national and international units are available. Okay, we already discussed this. That is, there are most commonly used units are Pascal, or we can say that bar. Okay, so keep in your mind that 100 Pascal is equal to 1 H Pascal, that is 1 hectopascal. Okay, and 1 H Pascal is equal to 1 millibar. Okay, you have to remember, or if you have to keep in your mind that these are the conversion factor. Conversion factor. These are the conversion factor. If somebody asks you what is mean by 100 Pascal, 100 Pascal is equal to how much millibar? How much millibar? So you have to convert in this way, in this order. Okay. After that, 1 hectopascal is equal to 1 millibar. Okay, and 1 millibar is equal to 0.001 bar. Okay, these are the unit to measure the vacuum, or we can say that pressure. Okay, so now I have one doubt and I have one question. What is vacuum used for? Okay, the question is that what is vacuum technology is used for, and measuring the pressure or vacuum. I have two questions. Okay, so first question is what is the vacuum used for? Why vacuum technology are needed? What are the application of vacuum technology or vacuum? Okay, so that to prepare a high quality of thin film, to prepare a high quality of thin film, or we can say that the application of semiconducting material, or we can say that to prepare a application of semiconducting material or semiconducting technology. Okay, so for that purposes vacuum technology are used. Okay, because to deposit a uniform layer by using the physical vapor deposition technology, or by using the chemical vapor deposition technology, such kind of vacuum systems are used. Okay, because to remove the other elements, to remove the unwanted air from that particular chamber. Getting my point? Or why vacuum is used? Because to accelerate an electron from that electron chamber. Okay, because if there is some air was present inside that electron chamber, or you can say that electron accelerator, so it creates a struck, it creates a resist. Okay, and then if we remove the air, if we remove the unwanted air from that particular chamber, so that we have to create a particular vacuum. Okay, vacuum is the technology to support that particular electron to rotate in a cyclic orbit with high velocity, okay. So vacuum technology is also used in the area of nuclear science and nuclear physics, in the area of material science, also in the area of nanoscience and nanotechnology also. Okay, so measuring the pressure or vacuum, we know by using the different methods, or by using the different systems, we can measure a pressure or vacuum, such as there are some techniques are used to determine to measure a pressure or vacuum, such as gauges. Some of the gauges are available, like Pirani gauges, like McLeod gauges. Okay, this kind of gauges are used to determine a vacuum, or to determine or to measure a pressure. Getting my point? So I hope that you might be clear from that particular slide about the concept of vacuum. Okay, so let's discuss about understanding of vacuum. Okay, so what is exactly vacuum is means what? How we can say what is meant by vacuum? So vacuum is the air is a gas mixture with approximately 10 raised to 25 particles per meter cube of air at 1 bar air pressure. Okay, 1 bar air pressure मध्ये किती air gas available असतो? That is, air is a gas mixture with approximately 10 raised to 25 particles per meter cube. Per that particular meter cube मध्ये किती प्रमाणात air gas available आहे? That is 10 raised to 25 particles per meter cube of air at 1 bar air pressure. At 1 bar air pressure. Okay, and particle exert pressure or force on the walls of the defined space. Okay, and wherever pressure was increases, that time that particle exerts a pressure on or force on that walls. If we increase the pressure, at the same time that particle was bombarded or shifted towards the wall. Okay, the fewer particles there are in the space, the lower the force exert on the walls. So what is meant by pressure? Pressure is nothing but a force upon area. Pressure is nothing but a force upon area. If suppose that there is some amount of area was present, suppose this is the area, okay, and if we apply a pressure, okay, or we can say this is the area, or if we apply some of the force on that particular area, so what will happen? There are some creates a pressure. Okay, there is create a pressure on that particular area. Okay, and at the same time pressure was developed. Okay, you know the natural gas formula, or we also seen some of the example. If there is some gas chambers are there, okay, and there is some volume are also present inside that gas chamber. Okay, there is one part and there is another part, and if we apply some pressure on that first part, so what will happen? Slightly inside that gas chamber, there are some molecules are present. So slightly, that particular part was shifted. Okay, that particular part was shifted. At the same time, that molecule, whatever that amount of molecules are present inside that chamber, that molecule was shifted. Okay, or we can say there is no shift was present. So at the same time, inside that chamber pressure was created. Okay, look at here. If this part was shifted in this area and this part was in a fixed position, so what will happen? In this zone there are some high amount of pressure was generated. Okay, you know pressure cooker. Okay, inside the pressure cooker there is some area, and you are applying the force by using the gas burner. Okay, at the same time pressure was generated, and due to that reason the gas that pressure cooker's alarm was coming out. Okay, so 100% vacuum would mean that there are no particle present. It means pressure is equal to zero. Pressure is equal to zero. So inside the chamber, if there is 100% of vacuum are available, it means that there is no other particles are present. Means by using the vacuum pump, we are remove all the vacuum particles. Not a vacuum particle, other elements or other particles we have to remove from that particular chamber. Okay, it means that at the same point pressure is zero. Okay, inside that chamber pressure is zero. Okay, if 100% vacuum are there, so it means that pressure is zero. So look into the second figure. This figure. Look it into this. This is the vacuum pump. This figure indicates a vacuum pump. Okay, and this one portion indicates a pressure side. Second one indicates a suction side. Okay, this one, second one. Third one indicates a inlet wall. Which one? This one. Fourth is the exhaust wall. Exhaust. This one. This one. And Last one is the piston. Five is the piston. This one is the piston. Okay. So look it into the carefully inside that figure. So what will happen? I will explain this figure firstly, and after that we will study the principle of vacuum technology. Okay. Otherwise, we have to read the principle of vacuum technology, and after that we will discuss that particular figure. Okay. The most important components are the jet nozzle, that is Venturi nozzle, and at least one receiver nozzle. Okay, receiver nozzle means to receive the air from that particular chamber. The most important component are the jet nozzle, and the at least one is the receiver nozzle. Accelerated compressed air generate a suction effect between both nozzle. Okay, so now look it into the figure. Look it into the figure. Suction side. Okay, this side, this second side was connected to the particular chamber. That is, we can say that this area was connected to the particular chamber. That is, we can say that chemical vapor deposition technique, CVD. We can say that PVD, physical vapor deposition, or we can say that electron accelerator also. Okay, so this second part was connected to the where that particular chamber where we need a to create a vacuum, where we need to create a vacuum. Okay, and first part was connected to the rotary pump. We can say that this first part was connected to the rotary pump, otherwise a diffusion pump. Okay, and what will happen exactly? That rotary pump was started at the same time. This fourth number, what is exhaust wall, and 3 is the inlet wall. If inside that chamber CVD, PVD, and second in this area, if there is some unwanted air was present, okay, in this area, if there is unwanted air or unwanted gas molecules are present, and from by remove that unwanted air, or to remove that unwanted air or unwanted molecule from that chamber, so we have to start the rotary pump. Or what will happen suddenly? The fourth part, exhaust part, was also open because that rotary pump was sucked, or they are catching that piston, or they are take it out that piston due to that particular pressure, due to that vacuum. What will happen? If rotary pump was started, simultaneously that exhaust part was automatically open, and simultaneously the inlet wall was also open. Inlet wall are also open. Okay, and it means if we stop the machine of rotary pump and diffusion pump at the same time, simultaneously 4 and 3 section was automatically closed down. Was automatically closed down. Okay, this part was automatically closed down. If we switch off the rotary pump and diffusion pump. Okay, now if we start the rotary pump, if we start the diffusion pump, or if we start the turbo pump, what will happen? All the unwanted air was sucked from that PVD CVD technique, and that unwanted gas molecule was present here then. Okay, was present here then, and then suddenly the exhaust valve was open. This valve was open. Okay, and after that all the gases molecule was coming out from this section. Okay, exhaust means to knock out the unwanted air from that particular space. Okay, you can observe the exhaust was everywhere available. If whenever you have to visit in physics department, or whenever you have to visit in physics department of computer laboratory, you have to see in the exhaust. Okay, inside the kitchen also available exhaust fan. Okay, exhaust fan. What is the role of exhaust fan? to remove the unwanted smoke, to remove, to suck the unwanted fog, or to remove the unwanted air from that particular area. Okay, so by using the exhaust valve, that rotary pump was suck that air and knock out from this zone. Okay, and in this area or in this zone, in this zone, there is high amount of vacuum was generated or high amount of vacuum was created. Okay, and if suppose all the air molecule or all the gaseous molecule was removed from that particular zone, so what will happen? Suddenly what will happen? From this area there is no other molecule was present. Okay, and if suppose there is no other molecules are present inside the inside this zone, that is CVD technique or PVD technique or electron accelerator technique. So simultaneously here this wall suction side, not suction side, inlet wall was closed down, means he is provide the signal to shutter down that part. Okay, this area was shut down and simultaneously exhaust valve was continuously started. If there is very little amount of gas molecule or little amount of any other particle, any other small amount of particle was present, so the role is that the role of exhaust valve is that to remove that particular air molecule or water molecule from that chamber. Okay, from this side. Okay, and here the 100% vacuum was present. It means there is a 0% pressure was there. Okay, inside the atmosphere there is 100% vacuum are there, means there is very less amount of pressure. And due to that reason, whenever we are traveling by flight, at that time that flight was goes in very higher height, and there is very little amount of pressure was present, very small amount of pressure was present, and due to that reason we are suffering some headache problem, we are our body was suffering some medical issue then. Okay, so I hope that you might be clear this figure, you might be understand this figure. So we have to read the principle of vacuum technology, and principle is that accelerated compressed air generated suction effect between both nozzle. Okay, both nozzle means which nozzle? This nozzle, that is nothing but a wall. Okay, there are different design principles: single stage and multi-stage ejectors. Means eject out, to remove or to suck the unwanted air from that particular chamber. So it may be a single stage or it may be a multi-stage. Okay, depending on the principle, air is either carried away in a flow by a rotating impeller on the suction side or compressed using van chamber. Okay, and the pump types available includes vacuum blowers and vacuum compressor. Okay, these are the example. The pump types are available includes vacuum blower and vacuum compressor. These are the types of pump. These are the types of vacuum pump or rotary pump or turbo pump. These are the type of pump to remove the unwanted air. Okay, so this is the principle of vacuum technology. I hope that you might be clear. So look at into the next figure, that is this figure. That is this figure. Okay, so this there are this is the chamber. This is the chamber. Okay, and there are number of gaseous molecules are present. There are number of air molecules are present. Large number of particles at a constant temperature and at high pressure. Okay, high pressure मध्ये number of particles जास्ती प्रमाणात present आहेत. There are large number of particles are present inside that chamber with constant temperature. Okay, at the same time pressure gauge shows a very high. Okay, this is the pressure gauge. This is the vacuum measurement technique. Okay, we will look in our next slide. There are different kinds of techniques are available, and whenever if we start the vacuum technology, Okay, here simultaneously the rotary pump was connected. Okay, rotary pump was connected, and rotary pumps creates a 10 raised to minus 3 torque vacuum. Okay, to measure a vacuum, there is one more unit, that is torque. Torque is also one of the unit to measure a vacuum. Okay, torque, TORR. Okay, so rotary pump creates a 10 raised to minus 3 millibar vacuum, or we can say 10 raised to minus 3 torque. And if we need a 10 raised to minus 6 torque vacuum or millibar vacuum, so you can't create that much amount of vacuum by using a rotary pump. So simultaneously you have to connect a diffusion pump here. Diffusion pump, that is DP. DP means diffusion pump, not Radha Patil College. Okay, diffusion pump. Okay, and by using this rotary pump, and this is diffusion pump. If we remove that particles or air particle or gaseous particle or unwanted particle from that chamber, so at the same time 100% vacuum was created. Okay, and if 100% vacuum was created, so pressure was decreases. So here there is some point was showing, so that is higher pressure, and if this all the molecule was sucking out from that chamber, so that pointer was goes down here in this side. Okay, it means that there is very less pressure was there. Okay, look it into the above figure. Look it into the above figure. You have to look in this figure. Okay, here only less amount of particles was present. Look it here. And as compared to this figure, here a large number of particles was present, and due to that reason very high pressure was there, and here very less pressure are there. And if pressure is zero, it means if pressure is zero, it means there are no other particles, or there are no other particles was present. It means vacuum is 100%. Vacuum is available in terms of 100%. In terms of 100%. Getting my point? So this is the system to measure a vacuum. Okay, this is, we can say this unit, this technique is nothing but a Pirani gauge, or nothing but a McLeod gauge, or there is nothing but a other gauge to measure a vacuum. Okay, these are the gauges to measure a vacuum technology, or to measure a vacuum. There is some of the gauges are used to determine, to measure, or to obtain a vacuum. We will see in our next slide. Okay, so I hope that till this slide you might be understand our today's lecture. I hope that you may be enjoy our today's lecture. Okay,